scatter plots and lines of fit. So a scatter plot is a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane, and scatter plots can show you different trends. All right. So this scatter plot on number 1 shows you the amounts X in grams of sugar. So the amount of sugar in grams, that's the X-axis, right? So this would represent like 46 grams of sugar, 50 grams of sugar, 54 grams of sugar, so on and so forth. And the number of calories in 10 smoothies. So these are the number of calories, right? All right. How many calories? So we're looking for a Y value, right? How many calories? That means we should identify a number on this side, right? The calorie side. Or in a smoothie that contains 56 grams of sugar. So I'm counting here. It looks like I'm counting by 4s, right? So if I wanted to find 56 grams of sugar, that would be halfway between 54 and 58, right? So this is 56 grams of sugar. I'm going to go all the way up until I reach the point that has 56 grams of sugar. Then I want to know how many calories is in that, though. So I'm going to shoot over to the left-hand side and identify that there are 270 calories in that milkshake. And always put your unit of measure, calories. All right, this time they're asking for how many grams of sugar. Grams of sugar is your X value, right? So you should have a number coming from this section of your graph, the sugar section. So how many grams of sugar are in a smoothie that has 320 calories? So you're going to locate 320 calories. That would be right here, correct? And I'm going to go over until I get to a point right there, right? This represents a smoothie that has 320 calories. And then you're going to shoot down to see how many grams of sugar is in that, and that gives you 70. So there are 70 grams of sugar in a smoothie that has 320 calories. All right. What tends to happen to the number of calories as the number of grams of sugar increases? So they're asking me what's happening with the calories, right? So as my sugar grams increase, what's going on with my calories? They're getting bigger, right? So we can say they increase or they get bigger. The calories increase. So in other words, you're just going to say, okay, if I have this many grams of sugar, I'm here, right? But if I have more grams of sugar, I'm a little bit higher. And more grams of sugar, I'm a little bit higher. And more grams of sugar, my calories just keep going up, right? Which kind of makes sense. True? All right, this scatter plot shows the amounts of time, X, in hours. So down here, we have time values in hours, right? So this would represent 4 hours, 8 hours, 12 hours. And if you're looking at your tick marks, you're counting by 2s, right? 2, 4, 6, 8, 10, 12. All right. I guess I need to read the rest of that. That 8 students spend on homework each week, and then their grade point averages are the Y's. So grade point averages over here, so 1 point, 2 point, 3 point, 4 point, and the in-betweens. All right, so we're counting by halves, right? Half, 1, 1.5, 2, 2.5, 3. That's always a good thing for you to decide in the beginning is what you're counting by. All right, so what is the grade point average? So are we looking for an X value or a Y value? A Y value, because this is the vertical axis, right? So grade point average of a student who spends 6 hours a week on homework. So I'm going to go over and find 6. So I'm counting by 2s, 2, 4. So 6 is right here. So I locate the 6, and I'm going to go up and find that student. But then I'm going to shoot over to see what their grade point average if they spend 6 hours a week on homework, and that would be a 2.0, right? Okay. how many hours a week, so this time we're looking for a X value, how many hours, so we're looking down here at the bottom. How many hours a week does the student who has a 2.75 grade point average spend on homework? So they're telling us 2.75. So that's like 2 3/4. Think of it in terms of money. Like if this is $2.25, this would be $2.50, $2.75, and $3, right? So we're about right here, halfway between the halfway. So I'm going to find that grade point average, 2.75, and I'm going to go over. That would be this student right here. I'm going to drop down, and that tells me that they spend 12 hours a week. So we'll say 12 hours per week, right? What tends to happen to the grade point average, so what's going on with our Y values, as the number of hours spent on homework increases? So as I spend more time doing homework, what happens to my grade point average? It is increasing, right? So we'll say it increases, which also makes sense. The more time you spend studying, generally speaking, the better your grade point average is. Is that always true? No. All right. But on average. All right, so we have some different types of correlation. So think of it in terms of, you read left to right, so we're going to think about this in terms of like a positive slope and a negative slope. So if I read my graph left to right, these are pretty tight together, right? I can see that they are going upward, so that would make a positive correlation. As I read left to right, these are going in a downward slant, right? So that would be a negative correlation. If you can't tell if it's going up or down, then there is no correlation. Now, sometimes you can have like a strong correlation, like these are really close together, or you could have like a weak correlation. They're still going up, right? But they're just not as close together. Number 3, we're going to tell whether the data show a positive, a negative, or no correlation. So down here we have a person's age, and then we have the number of vehicles they have owned. So do we have a positive correlation, a negative correlation, or no? Okay, these are like all over the place, right? I mean, you can't tell if they're going up or down. So that would be no correlation. So in other words, what they're saying is a person's age and the number of vehicles they owned, they don't have anything to do with each other. So I guess someone could be 50 and have owned the same vehicle since they were 17, right? I mean, typically speaking, people normally trade their cars in, so you would think that there would be a correlation, but I guess there's not. All right, temperature and coat sales. So if you're looking, you've got your temperature down here on the bottom, and then the number of coats sold every day. This is the temperatures increasing, right? So do you have a positive correlation, a negative correlation, or no correlation? Negative correlation. And I want to point this out. It makes sense, right? When the temperatures are colder, you sell more coats, right? But as the temperature increases, you sell fewer coats, which makes sense, right? People aren't buying coats when it's 80 degrees outside. All right, so now let's talk about lines of fit. So a line of fit is like an equation that we write to go with some data so that we have, you know, kind of like a line to compare something for maybe our business. So like I see how much I'm selling every week, and then I can kind of make a prediction on how much I'm going to sell at a specific point in time. All right, so what you will do is you'll get some data, and you're going to make a scatter plot. You're going to plot the dots, all right? And then you're going to decide whether this data can be modeled by a line. So in other words, if I've got some dots going like this, then yes, those are all kind of going in the same direction, right? I could model that with a line. But if I don't have a correlation, then I can't, right? So if there's no correlation, then you can't do that. So then you're going to draw a line that appears to fit your data closely. So you should have about as many points above your line as you have below it. So your line should be going through all the data points. And then you're going to write an equation using 2 points that fall on your line. They don't have to actually be points that are points in your table. They can be points that you pick on your line. Okay? So we're going to plot our data points. Right now we have a table that's talking about weekly sales of DVDs and the number of weeks since its release. Okay? Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and the y-intercept of the line. So they told you that your weeks are your x. So down here, you're going to say weeks. That's your x values, right? This is your x-axis. So we have 8 weeks here. So we're going to label these 1, 2, 3, 4, 5, 6, 7, and 8. So there's my x-axis. That represents this part of my table, right? Then we have our sales in millions. So over here you have sales. And you're going to make sure that you state that that's in millions. Now, if you look, you want to pay attention to the smallest number that you have, which is 5 million, right? And the biggest is 19. So I don't want to count by fives because that would be 5, 10, 15, 20, and I've already reached my top, right? But do I have 20 lines that I can label 1 through 20? Since 19 is my biggest? No. So maybe we should count by 2s. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right. So we're going to plot these points. So when I'm at 1 week, I should be at 19 million. So week 1. So I'm going to go up, not quite to 20, but we're counting by 2s, right? So 19 should be about halfway in between there. So week 2, up to 15. So 2, I know 15 is going to be halfway between the 14 and the 16, so I put a dot there. All right, week 3, we're going to go up to 13. Week 4, 11. Week 5, 10. Week 6, 8. Week 7, 7. And week 8, 5. Now that we've plotted all of our dots, what we want is we definitely see that this has a negative correlation, correct? So apparently, the farther it goes along, the less they've sold, right? So let's see here. Where's my line tool? So what we want to do is we want to make a line of fit. So just watch here before you start drawing one. Now, everybody's line of fit will not be exactly the same, right? But it's stated that you want a line that kind of follows your data points, right? So if I drew a line here, would that follow my data points very good? No. Or if I drew the line over here, that wouldn't, right? I want something that goes, and I have about as many points on top of my line as I do on the bottom. So I've drawn kind of in the center through here. So go ahead and draw your line in. And if you look, we've got 3 points below. We've got about 3 points above, right? And we got a couple that are like on the line, all right? Like I said, I mean, I probably could have drawn that maybe just a hair up just a little bit. Are y'all with me? Just a little bit. But it still follows our data pretty good, correct? So this is the line that we're going to write an equation for. So if we want to write an equation for a line, we need 2 points on the line, just like we did in the previous lessons. So if we want 2 points on the line, this point looks like it's on the line, correct? So I'm going to color that in maybe pink so we can let that stand out. And then I'm just going to kind of follow this till I find another point on my line. So that looks like a point that's on my line as well. It's really close, right? So I'm going to pick those two. Now I could have went with this one. That one looks good, right? And maybe this one. You just want to get 2 points that are on that line. They don't have to be points that are here. All right, is everyone with me on that? Just pick 2. So let's label what these points are. So this point is 2, 16. That's 1 point. And then this one right here is 4, 12. Now, all we have to do is write the equation of our line. So the first thing that we're going to find is our slope. So I'm going to take, since 16 is bigger, I'll do that one. 16 minus 12. And then on the bottom, I'll have to do 2 minus 4. So that's going to give me 2 over negative 2, which is negative 1. Negative 2. So we have 4 over negative 2. It's negative 2. All right, and then we're going to use one of these points because I don't know what my y-intercept is, correct? I'm not quite sure. I mean, I could try to extend that, but it wouldn't be accurate. So I'm just going to pick one of these points. It doesn't matter which one. I'm going to go with the 412. And I'm going to put this into point slope form. So I've got y minus, my y value is 12, is equal to my slope times x minus my x value, which is 4. Then I'm going to go ahead and do the solving for y. So I'll distribute my 2. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And then I'm going to go ahead and add the 12. So I get y is equal to negative 2x plus 20. And there's the equation of my line of fit. So the plotting of the points, that's not difficult. Picking 2 points on your line, like drawing your line through, that's really not difficult. Just make sure that you've gone kind of through the middle of all your data. And then this is stuff you already knew, right? So we're just kind of combining some information. All right, so this table shows the salaries in thousands of dollars of 5 architects and the number of years experience. So why? They told you that that's the salaries. So this is, I'm going to write this out to the side, salaries, and that's in thousands, right? We're going to need that when we do our graphs, right? And then, so this would be like 50,000, 55,000, 56,000, all right? And X is the number of years of experience. So number of years experience. Number of years experience. So 1 year of experience, he's making 50,000. 2 years of experience, 55,000. 3 years, 56, so on and so forth. So we're supposed to write an equation that models that data, all right, and interpret our slope and our y-intercept of the line of fit. So we're going to do this one in the calculator, so it will do all the work for us. So what we're going to do is we're going to make a table, all right, and the table has lists, okay? Those lists are list 1 and list 2. So list 1 is going to kind of be an L with a little 1. That's going to be all your X values. And in list 2, those are going to be all of your y values. Now remember, these are in thousands. Okay, so list 1, list 2. So you're going to grab your calculator. And we need to access our list. Now you would think that you would go to like a list menu. See how it says list right here above this button that says stat. But we're actually going to click on the stat button. All right, so click on stat. And then we want to do some editing. So I'm going to just press enter because that's already selected. So press the enter button and see how you have 2 lists here. Okay, so list 1, this is like a table, right? Like your X, Y table. Your list 1 is all of your X values. So you're going to take that table, which is 1, 2, 3, 4, 5, and you're just going to put those in. So I'm going to press 1, and then I'm going to hit enter and see how it moves down to the next slot, and I'm going to do that all the way through 5. So 2, enter 3, enter 4, enter 5, and make sure you press enter after that last one. So you should have the numbers 1 through 5, and then it should be highlighted below because it's waiting for another entry. All right. Then to get over to list 2, you're going to click this right arrow, and then it's going to pop you over into list 2, and you're going to put all of your y values. And you need to make sure you put them in the same order. So we went left to right, so you should go left to right. So we have 50, enter, 55, enter, 56, enter, 60, enter, 62, enter. All right, now we're going to tell the calculator what we want it to do. So we're going to go back to the stat menu. So click the stat button. But this time we want it to calculate. So we're going to arrow over because that's another menu. And we're doing a linear equation, right? Now, first things first. I know that we're writing an equation, so I'm going to back up just 1 second. I actually want to be able to see the points to make sure that they make a line. Are you with me? Like maybe there's not a correlation, and I didn't graph these by hand, so I kind of want to make sure. So we're going to tell the calculator to graph them. So if you go up here to your y equals, let's do this first. So go to y equals. This is where you would put in like equations that you wanted to graph. But up here, do you see how they have these plots? I want you to go up until you're blinking on top of plot 1 and press enter. And that's going to tell us, hey, we have some data that we want to plot. All right, so stay right here. I'm going to show you something. This right here is my graph button. So when I go to the graph, if you'll notice, do you see any points here? No. This is why. Your points are 150. That would be over 1 and up 50, but that's not in this screen, right? So what you have to know about a graphing calculator is this is just one part of an entire graph, right? I'm only looking at y values that go from -10 to +10, and I'm only looking at x values that go from -10 to +10. So if I want my calculator to look in a different spot, then I have to kind of, it's like a camera, okay? You got to tell it where to move. That's where this window button comes in. See how it says window? This is your window. So we need to change the window. So click on window. And if you look, see how it says your minimum x value is -10 and your maximum x value is +10? We want to tell it where to move. So what's the smallest x value you have? 1, right? So I don't want my x's to start at -10. I want them to start at 1, but I'm going to go a little bit below it, so I'm just going to choose 0. So click 0, and you should have a 0 right here. Okay? Now go to your maximum. What's the biggest x value you have in your table? 5, right? So does it hurt for me to go all the way to 10? No, so let's just leave it. We'll leave it at 10. I could change it to like 6, right, if I wanted to. This number right here, that just represents what I'm counting by, which really doesn't matter when I'm plotting points, so I'm just going to leave it. So for your y values, what is the smallest y value that you have in your table? 50. So maybe we should start at 45. So let's type in 45 right there. And then we're going to change our biggest y value, which is 62, so maybe we want to go to 70. Is it wrong if you go to 65? No. We just want to make sure that we've moved our window, right, so that the calculator is looking in the right spot. All right, now you can press this graph button up here so you can look at your points and see how your points are there. Okay, so we're in the right part of our window, correct? Now, do these form a correlation? Yes, a positive one, right? So we want to tell our calculator to make a line of fit for us, all right, instead of us having to do it by hand, all right? So we're going to go to that stat menu like we did a while ago before I backed up. So we're going to click on the stat, and we're going to tell it to calculate something for us. So we'll go over to this calculate menu, and we want to do a linear regression. That's what that's called. It's working backwards. So that would be option number 4. So we're going to press the number 4. Now, this is just asking you where all your data is. So this is saying, is your X in list 1? Yes, right? That's where we put the X's. So I'm going to press enter. Is your Y in list 2? Yes. So I'm going to press enter, and then I'm going to press enter till I get to calculate, and then I'm going to press enter again. All right, if you're on a TI-83, it's not going to show where the X and the Y list is, I guess. So just press enter, and you should get to this screen, right? Okay, so see how this is like Y equals MX plus B, but they put an A here, right? So they're telling you that the number in front of your X should be 2.9, and the number at the back, the B, should be 47.9. So on your problem right there, I want you to write the equation, y equals, and then you're going to plug in that A value for A, 2.9x, and then your B is 47.9, so plus 47.9. So right there below your table on your notes page, write that equation down. Now, I want to see if that line actually is a good fit. So I want to graph it and see if it goes through those points, right? So I'm going to go to the y equals, where we went a while ago, this upper left-hand button. And in this y1, this is like your y equals, we're going to put in the right-hand side of that, all right? So we're going to type in 2.9x, so I'm going to do the 2.9, and then to get an x, you see this button that's right next to this alpha button that has like the x and all that, that's your x button, so push the x, plus 47.9, 47.9. So I've put my equation in it, but when I want to look at the graph, I have to press the graph button. So go to graph, and if you watch it, it draws through your data points. So does that seem like a good line of fit for your data? Yes. All right. So this is just pretty much a step you don't have to do, but don't you want to know if it gave you a good equation or not? Okay. Video. So in the next video, we will go over the interpreting of the slopes, and we're going to go back and actually do this set of data in the calculator and see how close our line of fit was to the one that the calculator gives us, just so we can kind of see the difference.